All right. Thank you, Wendy. Good afternoon, ladies and gentlemen. Welcome to this afternoon's webinar presentation with AIA Florida. Today's program, as Wendy said, is 1 hour wind mitigation opening protection under the Florida Building Code residential. And this does come out of the 8th edition of the code. So first thing, as Wendy said, show you your credits here, 1 hour for health, safety, and welfare. My name is John Farinelli from JC Code and Construction Consultants, and I will be your instructor today and appreciate the opportunity to be with you here today. So, a little bit of course overview. Now, when it comes to design parameters, ASCE 7 states that the design professional must consider all loads that the building or structure is exposed to: wind, rain, flood, seismic, snow. Well, obviously, seismic and snow aren't a consideration here. So the design factor in Florida, wind. Wind loads are one of the most important design considerations of a structure. And high wind areas, such as Florida, wind loads are usually the governing design factor. So we will discuss wind load effects, the protection of glazed openings, and required product approvals. So let's go over a little background information first thing out of the gate. Why does the code require glazed openings to be protected? Well, during a hurricane, buildings are impacted from windborne debris due to high velocity winds. This debris can impact the glazing, causing breakage and creating an opening within the building envelope. The presence of openings in the building envelope can have a significant effect on the magnitude of the total wind pressure required to be resisted by each structural element of building. Now, something else to always keep in mind, the building code volume in ASCE 7, and accordingly, the residential code talks about two different items, so to speak. The main wind force resisting system, the structural components of the building, but it also talks about components and claddings. Those are items that are exposed to wind load, but do not have any structural benefits to the building itself. Roof coverings, windows and doors, siding, soffit material, all considered components and cladding. So depending on the location of the openings with respect to wind direction and the amount of background porosity, external and internal pressures may act in the same direction to produce higher forces on some walls and the roof. Wind is an amazing thing. When wind encounters a stationary object, such as a building, the airflow changes direction and produces several effects on the building. Exterior walls and other vertical surfaces facing the windward side, and perpendicular to its path are subjected to inward or positive pressures. However, the wind does not stop on contact with the facing surface. It flows around. It flows around and over the building. And the airflow does not instantaneously change direction at surface discontinuities, such as the corners of the walls or the eaves for that matter, or over the ridges and roof corners. Instead, it separates from the downward surfaces due to high turbulence and localized pressures, resulting in outward or negative pressures. Negative pressures. And this phenomena produces suction or outward pressures, negative pressures on the sides, the leeward wall, and, depending on the geometry, the roof. And here's a real good shot of what ends up happening when that window or sliding glass door or garage door gets blown out of the opening. During a hurricane, buildings are impacted from wind-borne debris due to high-velocity winds. And this debris can impact the glazing, causing breakage and creating an opening within the building envelope. And the presence of the openings in the building envelope can have a significant effect on the magnitude of the total wind pressure required to be resisted by each structural element of the building. And that's exactly what happens. The opening is compromised. Internal pressure increases inside the structure. So not only do you have the outward pressures, uplift on the roof and such, the internal pressure goes up. Now you've got a double set of forces that are impacting the structure. So you end up with both positive and negative pressures when the windows and doors fails and such. And this can lead to a catastrophic damage of the structure. Now, fortunately, newer constructed buildings, and it doesn't matter if they're constructed under the residential code or the building code volume. But for many, many code cycles now, the code has required a continuous load path. But that wasn't always part and parcel of the code. And even these days, even though the code requires a continuous load path, if the load path is weak or compromised, you can end up with this. Once the integrity of the building envelope is compromised, the buildup in internal pressure can lead to failure of the roof. And once the roof is gone, the entire structure and all of the contents are destroyed by wind and rain. And you can see here, this is where the doors were. They got blown out. And all the roof sections here and here to the right, gone. Gone. Because of a load path that wasn't properly constructed. And it's amazing when you look at it. Look at this. This gable end is still standing and everything else is gone. It's incredible. The back section here, he lost a little bit of the roof covering, but that was about it. So it just depends on many, many factors. Wind directionality, wind pressures, but clearly you can see here the result of a failure of the load path. Now, I don't have to tell everybody about the recent hurricanes that we've had. Here's good old Hurricane Milton. And I saw something on the news this morning on the internet that they've finished reviewing the pressures and such of Hurricane Milton. And it ended up being one of the most powerful hurricanes to hit Florida in quite some time. But also, you have to worry about the storm surge. Storm surge around Tampa was 6 to 9 feet. The lower portion, Sarasota, Port Charlotte, 9 to 13 feet. 9 to 13 feet. So not only do we have to worry about wind loads, we have to worry about flood loads. And something else that came up during Hurricane Milton was the craziness of these tornadoes. Look at this one that ran through Fort Pierce. Look at the peak winds, 155 miles an hour. Now, just as a side note, change in the 8th edition of the codes, according to ASCE 7, is building risk categories 3 and 4 must now be designed for tornado loads. Now, I do have a comment here from Mr. Anonymous. Would an opening in the leeward wall permit wind to pass through a space and reduce the overall external forces? And the answer to that is pretty much no. No, because what happens when the wind changes direction? Because remember, hurricanes spin counterclockwise. So if the wind changes direction, and now it's the windward wall, and if it's already blown out, the old wives' tale about opening windows on both sides of the structure to let the wind pass through, that's exactly what it is, an old wives' tale. Good question, though. Thank you. Appreciate that. All right, now, in good old US of A, we call them hurricanes. But in other parts of the world, they call them cyclones or typhoons. Well, a rose by any other name, they're all the same, but distinctive terms are used for a storm in different parts of the world. As we said, they're called hurricanes in the Atlantic, the Caribbean Sea, Central and Northwest Pacific. But in the Northeast Pacific, they're called typhoons. And in the Bay of Bengal and the Arabian Sea, they're known as cyclones. But again, a rose by any other name would still be a potential disaster. All right, let's move forward now, and we'll go to the code itself, and we'll look at Chapter 3 out of the Residential Code, Building Planning. First thing is R301.2.1, Wind Design Criteria. Buildings and portions thereof shall be constructed in accordance with the wind provisions of this code, using the ultimate design wind speed in table, the ultimate design wind speed in table R301.2 as determined from figure R301.2 where different construction methods and structural materials are used for various portions of a building, the applicable requirements of this section for each portion shall apply. Now, this section does continue. Where not otherwise specified, the wind loads listed in table R301.2 shall be adjusted for height and exposure using table R301.2 shall be used to determine design load performance requirements for wall coverings, curtain walls, roof coverings, exterior windows, skylights, and exterior doors, other than garage doors. Where loads for garage doors are not otherwise specified, the loads listed in table R301.2 adjusted for height and exposure using table R301.2 shall be used to determine the design load performance requirements. All right, let's stop right there for a second before we continue with this section, because there's something we do need to talk about here. This language, where not otherwise specified, and then it references you to the table. The residential code has a prescriptive table in it that will provide you the opening design pressures and the uplifts and the positive pressures on roof coverings prescriptively. You're going to see here that the table is based on an exposure B with a maximum mean roof height of 30 feet. Now, we're not otherwise specified. In other words, a design professional using ASCE 7 can calculate the pressures for the components and claddings and on the roof. Pick one. They're either calculated or you use the prescriptive values. If using the prescriptive values out of the residential code, and you're in an exposure category other than exposure category B, or you have a higher mean roof height than 30 feet, that's when you have to use the adjustment factors in table R301.2.3. Now, notice where it says other than garage doors, because as we said, all of these items here that you're looking at, wall coverings, curtain walls, roof coverings, exterior windows, skylights, and exterior doors, those are all components in cladding. And those are all the things we need product approval for. Now, why does it do other than garage doors? Well, there's a reason for that. And it's the same deal where the loads for the garage doors are not otherwise specified. In other words, again, not calculated from ASCE 7. There is a prescriptive table in the code for garage door pressures. Now, the reason for it is garage doors have a larger area than your average window or sliding glass door or French door. And then the larger area allows the wind to be spread out over a larger area. Therefore, the pressures are different. You know, if you take a sliding glass door next to a garage door, well, which one of those openings are going to have the higher pressure on it? Well, it's going to be the sliding glass door because it's a smaller opening. That's the way it works. Now, I think I do have number, let's see. Another anonymous commenting that they have friends living in Spanish lakes. They were drastically affected by Milton, and he personally observed the tornado damage. Yeah, it was incredible, sir. I understand that, and that's a tragic, tragic situation. Uh, Hopefully everything works out for them. All right. Yeah. And Steve Wilcox, he's from Vero Beach. Yeah, it went zinging right through Vero Beach there. All right. Let's continue with this section. Code further states that asphalt shingles should be designed for wind speeds in accordance with section R 905.2.4. Metal roof shingles shall be designed for wind speeds in accordance with section 905.4.4. And here's the language that we've been touting. A continuous load path shall be provided to transmit the applicable uplift forces from the roof assembly to the foundation. And that's where your continuous load path runs from the roof sheathing, trusses connected to the wall below, all the way down to the foundation, through the foundation, and spreads the forces out through the soils. All right, let's talk a little bit now about wind pressures. A 50-mile-per-hour wind only pushes on a window or door with about 5 to 7 pounds of force per square foot of area, where a 100-mile-per-hour wind applies 20 to 28 pounds per square foot, and a 130-mile-per-hour wind applies 34 to 47 pounds per square foot. And these forces are applied on every square foot of a window. This means that a bedroom window that is, say, 3 feet wide by 5 feet long, when subjected to a 100-mile-an-hour wind, has between 300 to 420 pounds of force applied to the window and the frame. It's incredible what the wind can do. And always keep in mind, too, that the higher you go up in a building, the pressures increase. The pressures increase. Because once you get up, let's say into a multi-story structure, 5, 10, 15, 20 stories. Well, there's nothing up there to break up the wind like there is down on the ground area. You don't have other structures additional to it and so on. Pressures can go up dramatically. Now, looking at our table, this is your wind design, speed, topographical effects, special wind region, wind-borne debris region. This table is generic in nature to where each local jurisdiction must complete it and provide the information to design professionals in that area. Now, notice wind speed footnote D. Wind speed shall be determined from the basic wind speed map, figure R301.2 Wind exposure category shall be determined on a site-specific basis in accordance with section R301.1, or excuse me, R301.2.1.4. So the next thing we need to look at is that wind speed map, figure R301.2 and it did change in the 8th edition of the code. Let's take a look. Now, to the left-hand side here, I'm showing you the 7th edition wind speed map. And as you can see, here we are, basic wind speed, wind-borne debris region, shaded in gray, a little bit up here in the panhandle, all down here through South Florida. And notice you have 6 notes to the table. Well, look what happened in the 8th edition of the code to the right-hand side. Now, this is all changed because of changes in ASCE 7. Look at the panhandle. The wind-borne debris region got bigger, and they added another gradient line for the wind speed of 160 miles an hour. They also added another gradient line down in the dry Tortugas there for 180 miles an hour. But also, you have new footnotes number 7 and new footnotes number 8. Now take a look at this, and this is important, okay? When the code was first printed, these new footnotes made a change to how the windborne debris region was calculated. Within 1 mile of the mean high water line where an exposure D condition exists, upwind at the water line, and the ultimate design wind speed V ult is 130 miles an hour or greater. Now, footnote number 8 was added based upon ASCE 7. Location-specific wind speeds permitted to be determined using the ASCE Wind Design Geodatabase. And the ASCE Wind Design Geodatabase can be accessed at the ASCE 7 Hazard Tool. And then they give you the website or equivalent. Now, I imagine some of you were familiar with the Applied Technology Council, ATC, where you could go on their website and get a site-specific wind speed for any address in the continental United States and in some places out of the United States. But with the advent of the ASCE Wind Design Geodatabase, the ATC website for wind is gone. It's gone. Now, there was an uproar when this exposure D condition came into the code. And the reason for the uproar was because of the exposure D condition, it would greatly expand the windborne debris region. Here's just a good shot here of showing you how much bigger the windborne debris region got. It covered the entirety of this barrier island to a certain point, and look how far inland it came in. All per ASCE 722. There was a lot of discussion about that, and the building commission got involved. And in essence, I'll spare you all the boring details, but the commission took action. And they went back to the definition of the windborne debris region that was in the 7th edition of the code, because they felt that they could find no basis in scientific reasoning, because there's really no research done from what we could find, to go to that exposure D condition. So they went back to the definition of the windborne debris region in the 7th edition of the code. Areas within hurricane-prone regions located in accordance with one of the following. 1. Within 1 mile of the coastal mean high water line where the ultimate design wind speed V ult is 130 miles an hour or greater. 2. In areas where the ultimate design wind speed V ult is 140 miles per hour or greater, or Hawaii. And that, ladies and gentlemen, took effect by supplement number 2 to the code, August 19th, back in 2024. So that solves that problem. Now, I would like to share with you a little bit of the ASCE 7 hazard tool. And this is a really, really good site, because in addition to getting a specific wind speed and such, it also gives you flood information. Now, if you take a look at it, okay, first thing, you input the location. Once you input that location, the tool will generate the elevation. It'll give you the latitude and longitude. And there it is, ASCE 7 2022. You have to input the risk category. In this particular case, I put in risk category 2 because it was a single family dwelling. And look at the wind speed. Gives you the flood zone, AE. You can ask for the details. Gives you the summary. And it'll generate the wind speed. Take a look over here to the right. Hurricane prone region. Wind speed. Gives you everything you need right through here for this site. So it is an excellent, excellent tool. So, and as I said, not only does it give you the wind speed, but it gives you flood design information. Take a look at this. Here's the LMWA, the limit of moderate wave action. Here's the site. It is landward of the LMWA. It is a zone AE. and the base flood elevation is 12 feet. It is in a special flood hazard area, but it's not a V zone. Because if you look seaward of the Lemois, it's all a VE zone. Elevations go from 13 to 14 feet. It's a high velocity, it's a coastal high hazard area. So again, a very, very good site. A lot of information available there. Absolutely. All right, moving forward now, and let's talk about the protection of openings under R301.2.1.2. Exterior glazed openings in buildings located in windborne debris regions shall be protected from windborne debris. All right, hold on before we move forward here. All right, I have a comment coming in. They're asking what the Lemois is. All right, so let's back up the truck because that's important. All right, here it is right here. Limit of moderate wave action. It's called the Lemois for short. And that's this line with the triangles on it. And what the Lemois indicates by the limit of moderate wave action on the seaward side of the line, where you have the coastal high hazard areas. These areas are predicted to have wave heights 3 feet or greater during a wind event. On the other side, the Lemois side, the landward side, you have wave heights in a coastal A zone of between 1.5 to 3 feet. Now, if this area landward of the Lemois is deemed to be a coastal A, you have to design structures in the coastal A the same way you would design for a coastal high hazard area, a V zone, which means you must elevate the lowest horizontal structural member at or above the base flood line. Now, just because you are landward of the Lemois doesn't mean you're in a coastal A. There's a lot of factors that come into play there. Like, for instance, this is pretty much just an A zone here. So you would just elevate, per the code, base flood plus a foot. But anything seaward of that line, it's a coastal area, coastal high hazard area. And he's also asking, why is there an AE 13 feet seaward of the Lemois? Well, if you look at some of these areas here, it varies 13 feet, 14 feet, 15 feet. Here, it's actually out here, it's 16 feet. It's not a buildable area, of course, but they still give you the elevation that you would need. Back in here, it's 12 feet. Notice how it goes to 11 here and 10 here. So again, very, very good site. Very good site. All right, thank you for those questions. I appreciate it. All right, so going back to protection of openings now. Exterior glazed openings in buildings located in windborne debris regions shall be protected from windborne debris. Glazed opening protection for windborne debris shall meet the requirements of the Large Missile Test of ASTM-E 1996 and ASTM-E 1886, as modified in sections 301.2.1.2.1, TAS 201, 202, and 203, or AMA 506, as applicable. Garage door glazed opening protection for windborne debris shall meet the requirements of an approved impact resisting standard or the ANSI DASMA A or ANSI DASMA 115. Now, something to mention here. These two test standards, ASTM E 1996 and 1886, these have been around as far back as I can remember. However, the TAS, this is the testing application standard that comes out of the high velocity hurricane zone test protocols volume, where they test for wind pressure, impact, and static water. We'll look at this a little bit closer here shortly. But when you look at your product approvals, you're going to see just about every impact protection device is tested per the ASTMs and the TAS. Because if it's not tested per the TAS standards, you can't use those products in the high velocity hurricane zones of Dade and Broward County. So manufacturers cover their bases, they test to all the standards. All right, now this section continues. These have been in the code for a while too. Number one, openings in sunrooms, balconies, or enclosed porches constructed under existing roofs or decks are not required to be protected, provided the spaces are separated from the building interior by a wall, and all openings in the separating wall are protected in accordance with this section. Such space shall be permitted to be designed as either partially enclosed or enclosed structures. And you see that pretty typically on condos where people want to take those balconies and enclose them with aluminum enclosures, maybe acrylic windows or even glazed windows. And that's fine. As long as the sliding glass door or the French doors or whatever leads to that balcony are impact protected. Number two, this was in the code, put into the code by statute. Storage sheds that are not designed for human habitation and then have a floor area of 720 square feet or less are not required to comply with the mandatory windborne debris impact standard of the code. And when you think about that, that makes sense. I mean, it's a storage shed. Who cares if it's impact protected or not? Now, there are some exceptions here that deal with generic or prescriptive methods to protect glazed openings. What are we talking about? Plywood. Number one, wood structural panels with a minimum thickness of 7/16 inch and maximum span between lines of fasteners of 44 inches shall be permitted for opening protection in group R3 or R4 occupancy buildings with a mean roof height of 33 feet or less, where VLT is 180 miles an hour or less. Panels shall be pre-cut to overlap the walls such that they extend a minimum of 2 inches beyond the line of fasteners and attached to the framing surrounding the opening containing the product with the glazed opening. Panels shall be pre-drilled as required for the attachment method and secured with corrosion-resistant attachment hardware permanently installed on the building. That change that you see there, minor change, but that happened in the 5th edition of the code, which eliminated the use of tapcons, concrete masonry screws. The attachment hardware has to be permanently installed. 1A, attachments shall be designed to resist a component and cladding loads determined in accordance with the provisions of ASCE 7, with corrosion-resistant attachment hardware provided and anchors permanently installed on the building. Now, the exceptions go on. They give you an alternative here. As an alternative, panels shall be fastened at 16 inches on center along the edges of the opposing long sides of the panel. And then they give you, again, prescriptive methods for both wood frame and masonry construction. I is wood frame. Fasteners shall be located on the wall such that they are embedded into the wall framing members, nominally a minimum of 1 inch from the edge of the opening and 2 inches inward from the panel edge. Permanently installed anchors used for buildings with wood frame wall construction shall have a threaded portion that will be embedded into the wall framing based on 1/4 inch lag screws and shall be long enough to penetrate through the exterior wall covering with sufficient embedment length to provide an allowable minimum 300 pounds ASD design withdrawal capacity. And then 2, here is your masonry or concrete. Fasteners shall be located on the wall a minimum of 1.5 inches from the edge of the opening and 2 inches inward of the panel edge. Permanently installed anchors in concrete or masonry wall construction shall have an allowable minimum 300 pounds ASD design withdrawal capacity and allowable minimum 525 pounds ASD design shear capacity with a 1.5 inch edge distance. Hex nuts, washer wing nuts, or bolts used to attach the wood structural panels to the anchors shall be minimum 1/4 inch hardware and shall be installed with or have integral washers with a minimum 1 inch outside diameter. And then I, vibration-resistant alternative attachment designed to resist the component and cladding loads determined in accordance with the provisions table R 301.2, paren 2, or ASCE 7 shall be permitted. So bottom line there, folks, you can still use plywood, but it has to be installed per the prescriptive provisions, either for wood frame or masonry construction. Now, I have another comment here from another anonymous attendee. Does temporary plywood cover over existing windows installed at hurricane notification need to meet these standards? Okay. You always have to remember that the residential code, just like the building code, is for new construction. New construction. So when building a new house, let's say, or a new townhouse or two-family dwelling that falls under the scope of the residential code, and you're in the windborne debris region, you can, in lieu of using tested, product-approved impact protection devices or impact-resistant glazing, you can use plywood, but you have to install it per these prescriptive provisions that we just looked at. Now, if it's an existing building built whenever, and it's in the windborne debris region, this code does not apply to that. They can pretty much do whatever they want. If they want to put up plywood per these provisions, have at it. If you still want to use some plywood and throw it up there with Tapcons on it, have at it. Have at it. This is for new construction. And Humberto, current changes to the Florida Building Code regarding wind mitigation are highly significant. At times, we overlook crucial aspects that have now been updated. And that is true, sir. That is true, sir. And from Ed, going back to the Limois, is there an AE elevation 13 zone waterward of Limois? Is this an error? Okay, I'm not sure what he means by waterward, but we can go back. Let's go back real quick, because again, this is important. And I'm not sure where he's talking about when he says waterward. I'm guessing maybe here. It's here. That is 13 feet here. But no, there is no errors in this thing. This is from ASCE 7. Or let me rephrase that. There are no errors that I am aware of. It is accurate. All right, now going back where we left off here. And Steve has a question. Does the zip system OSB sheathing meet the FBC standards for protection of opening? According to the American Plywood Association, oriented strand board, which zip board is made from, is considered structural sheathing. So I would say yes. Yes, zip board would work because it is OSB sheathing and it is deemed structural by the American Plywood Association. And Thomas is asking, have you seen shutters designed with plywood and trim with heavy stainless steel fasteners and hinges to meet these provisions? No, I have not. No, I have not. Because I don't see how you could do it with hinges. If you remember looking at these provisions prescriptively here, they were quite clear about how the panels had to be anchored. Doesn't say anything in here about using hinges. But again, if somebody wanted to do that on an existing home, have at it. If that's what they want to do, if they were comfortable with it. Because remember, again, this is for new construction. And from Anonymous, will the insurance industry use the temporary plywood covers on existing residents against the homeowner if they do not meet these requirements? Well, that's pretty much up to your insurance carrier. If you're trying to do a wind mitigation inspection, and you have to look at your individual insurance company. And if I remember correctly, in the wind mitigation form from Citizens Insurance, there is a section in there about the use of plywood, if I remember correctly. All right, now, as far as testing the products, wind testing for wind load, we're testing for wind load resistance is based on allowable or nominal wind loads. The design loads determined in accordance with ASC 7 or section 1609 of the Florida Building Code building are permitted to be multiplied by 0.6 for the purpose of wind load resistance testing. Now, clearly this talks about ASC 7 or section 1609 of the Building Code volume. So basically, when a design professional calculates their opening design pressures per ASCE 7, they're allowed to hit those with a 0.6 multiplier to reduce the loads. Now, when you compare that to the prescriptive table in the residential code, those values for the opening design pressures already include the 0.6 multiplier. So, determining the opening design pressures. We've all seen this figure. It's both in the residential code and in ASCE 7. We've all seen this. Here's zone 4, zone 5. The width is 4 feet in all cases. And remember that your mean roof height is halfway between the ridge and the eave. Your opening design pressures are always highest at the corners, and the negative pressures are always the highest. So if I'm doing a plan review, or if I'm selecting product because I'm building something or I'm designing something, I'm going to look for the smallest opening in zone 5. What's the negative pressure? If the product I want to install in the structure meets that negative pressure for the smallest opening, I'm done. Because if it meets the negative pressure in zone 5, it'll meet the positive and negative design pressures everywhere in the building. So we're good to go. Now, something else to share with you here. We had a change in the 8th edition of the code. What I'm showing you up here in red is zones 4 and 5 out of the 7th edition of the code. Notice that the 500 square foot area has been struck from both zones 4 and 5. What I'm showing you down here in the black is that same section of the table in the 8th edition of the code. Notice it just goes 10, 20, 50, 100. But what they did do, and I still can't understand, is why they added more columns. They added column for 90, 95, and 100-mile-an-hour winds, and 105 and 110. This is only a partial piece of the table. There's no place in the state of Florida where you have wind speeds this low. So I can't explain to you why they put those columns in there, folks. Now, that said, here is the table. Here's the walls, 4 and 5. And notice, this is what I was talking about. Table values have been multiplied by 0.6 to convert component and cladding pressures to ASD. So if you use the values in the prescriptive tables, these are the values. End of the story. No further math calculation is needed. Now, again, remember, this table is mean roof height, exposure B. If you go to a different exposure category or a higher mean roof height, you have to use the multipliers. Notice, exposure B, mean roof height 30 feet, the multiplier is 1. Well, if you've got a lower mean roof height, look what happens in exposure B. You've got multipliers that are less than 1. That's going to bring the pressures down. Absolutely. Now, what I wanted to also point out to you, in exposure B, in this red box, you see these multipliers. This was in the 7th edition of the code. To the right here in red are the values in the 8th edition of the code. Notice they've come down. Not a lot, but a little. Now, something else to point out to you. As I've showed you previously, items in red, which indicate a change in the 7th edition of the code. For the 8th edition, they're using a blue font to indicate a change in the code. However, be really, really careful if you're using the code online. Take a look at this. See these values I'm showing you now in blue? Well, you would think that that would indicate a change in the code. It's not. The values here and here are the same as the 7th edition of the code. So the bottom line, folks, just because it's in blue doesn't necessarily mean it's a change in the code. Be real careful with that. Now, we mentioned earlier about sliding glass doors. I'm showing you here a partial section of the table. Garage doors, again, mean roof height 30 feet, exposure B. It is already in ASD. It's already been converted. Now, some people have always asked the question, well, wait a minute. A garage door, due to their size, it can be in zone 4 and zone 5 at the same time. Well, look at footnote number 4. Negative pressures assume door has 2 feet of width in the building's end zone. So they've already taken care of that. And again, it's already been hit with the 0.6 load reduction factor. So these values are these values. All right. Moving on now. Let's talk a little bit about impact testing and product approval. We've all seen what can happen. Windborne debris is basically anything that is picked up and carried by the wind. So not only are glazed products susceptible to windborne debris, so is the structure itself. Okay, I have another question here. What does ASD stand for? That is the nominal wind speed versus the ultimate. All right, the code allows for 2 types of protection systems, depending on the location within the state. In the high velocity hurricane zones, Broward and Miami-Dade counties only, all openings must be impact rated or protected. This means all windows, doors, skylights, and glass block. In the balance of the windborne debris region, only glazed openings on the structure must be impact rated or protected. This includes windows, sliding glass doors, skylights, doors, and garage doors with windows, but not glass block. All right. And let's see from Angel. Okay, he's saying he's not comfortable with architects making discussions or decisions on the items in this webinar. Well, Angel, I've got to disagree with you. You know, architects, they are qualified. They are registered design professionals. They are qualified to design structure, but it's up to the individual architect to determine whether or not they want to design structure or if they want to retain an engineer. But from a statutory standpoint, architects are absolutely qualified to design structure. All right, now I have another question here, and they want to go back to the table. Garage doors. For an 18 by 9 garage door, do we use the 16 by 7 line on table, or would it be more stringent? Well, again, if you look at the door size, it's limited to 16 feet wide, 7 feet high. So if you've got a garage door that's bigger than that, the pressures are actually going to be less. So you would use the 16 by 7. Because remember, the larger the opening, the less pressure you're going to have, because you've got a bigger area to spread the wind load out. So yes, for an 18 by 9 garage door, you would use the 16-7 line. Good question. Thank you. All right, come on, computer. All right, let's go back now. Ended up talking about the difference between the 2 types. Now, I do have a little video to show you here, and let's see if we can get this puppy to work. Come on, computer.
In 1992, Hurricane Andrew caused massive damage to Florida coastal communities, demonstrating that intense wind alone is not the major cause of window or door shattering, but the real damage is caused by flying debris, compromising the building envelope. As a result, building codes for hurricane protection include impact-resistant protection for windows and doors, not just wind velocity. The first state uniform building code in Florida came into existence in 2002. It was written in 2001 as a result of the Florida legislation responding to the need for more firm and regulated building codes after Hurricane Andrew. PGT manufactures the nation's leading impact-resistant windows and doors. The products are tested to withstand the most stringent building codes. All windows and doors are tested for impact using a 9-pound 2x4x6 beam traveling at a speed of 50 feet per second. The beam is carefully loaded into a cannon. After the beam is fired, the window is then subjected to hurricane-force winds. The beam passes through conventional glass, offering little protection and security against wind-borne debris. While 4 times stronger than regular glass, the beam easily passes through the tempered glass, offering little protection and security against wind-borne debris. The beam strikes the PGT wind guard window. The glass cracks on impact, but the inner layer keeps the glass intact, reducing the risk of wind-borne debris penetrating the window opening. Since the window opening is not compromised, this allows for a safer environment during high winds. PGT WindGuard impact-resistant windows and doors, keeping you safe before, during, and after the storm.
All right, a couple of things here, folks. First off, I'd like to make it clear that I am not hawking PGT products. I own no stock. All my money's tied up in bills. They just had the best video. Simple as that. Now, one other thing. I think most of us have a bucket list, and on my bucket list is shooting things out of an air cannon. I think that'd be cool. But also on my bucket list, I'd also like to drive the Oscar Mayer Wiener wagon. I think that would be fun. Hey, you got to have a little bit of fun doing this, okay? All right. Now, mentioned earlier about the ASTM standards. This is the 1886 standard test method. Performance of exterior windows, curtain walls, doors, and storm shutters impacted by missiles and exposed to cyclic pressure differentials. And then the 1996. This is your major impact test in here. Cyclic pressure is where they get the opening design pressures, positive and negative. And here is basically your impact test, impacted by windborne debris and hurricanes. Now, all right. Something that I want to show you, because remember, we already mentioned that we have the 1886, the 1996, but we also have the TAS 201, 202, and 203. So looking at this, okay, the 201 is impact, okay? While the ASTM E 1996 and TAS 201 are designed to determine the ability of an impact-resistant system to withstand the impact of flying debris. But unlike the ASTM, the TAS standard adds a second impact for large missile. Note that the pass-fail criteria is also different. It is anticipated that when the ASTM E 1996 is updated, that it will require each light of glass to be impacted twice along with the framing members, but that hasn't happened yet. Okay. Now I want to point out some to you here. Here's the 1996. Here's the TAS, okay, for large missile. 2x4 lumber. ASTM dead center, lower left, upper right. No tear permitting a 3-inch spear to pass through, no tear longer than 5 inches. The TAS 201 doubles it. 3 separate specimens are tested just like the ASTM, but it's dead center, lower right each time. No tear longer than 5 inches and a 1/16 of an inch in width. Now look at your missile levels. B, C, D, and E. We really don't use C and B. Okay, that's ASTM. We don't use that here in Florida. It's missile level D and missile level E. All products are tested by default to missile level D. Notice the difference, 50 feet per second. Missile level E, it's tested at 80 feet per second. When you have a design of a hospital or a nursing home, the code, the building code volume, requires a missile level E protection. So be very careful with that. In some cases, the code will require a level E. A level E. Now, something else. Small missile. 10 2-gram steel balls. Well, it's similar, okay? It's similar as far as the pass-fail goes. But there's one little caveat to this. If you pass large missile, you're automatically approved for small missile impact protection. And the reason for that, notice under the TAS 201, no tear longer than 5 inches and 1/16 of an inch in width. Well, these 2-gram steel balls, they're bigger than that. So as long as you pass the large missile, you're automatically past the small. Yep. Yep. So again, just be careful. Level E protection for essential facilities. All right, now to wrap this puppy up real quick. Come on, computer. There we go. I wanted to show you this. Notice ASTM standards listed. Level of protection, basic, wind zone 4, less than or equal to 30 feet, above grade. Here's missile level D, right here. Risk category 2 and 3 buildings. And if you're going to go to risk category 4, essential facility, it's 80 feet per second, missile level E. And oh, Tom. He wants to know what the wind impact is on the Wienermobile. Thank you for that, Tom. That's funny. All right. And from John, the code seems to be requiring that we meet standards like ASTM, ANSI, NFPA, or ASCE. Yet most don't have free access to those publications without paying exorbitant rates. Is there a calculation of the cost of having access to these standards? Unfortunately, John, no. Unfortunately, the only reference standard out of the code where there is free access that I'm aware of is NFPA. All the others, yeah, you're going to have to pay the freight. All right. To bring this puppy home, show you a shot here of product approval. Always check it. You got to have product approval for all your components and cladding, and remember to check the limitations of use. And it's amazing what some people do out there. Let's go ahead and put the plywood to protect the glazing on the inside of the glass. Oh, well. And then let's go put an armor shield and then cut a hole in it for an air conditioner. Doesn't do you a lot of good, does it? All right. Well, ladies and gentlemen, that is all I've got for you today. I hope you enjoyed the presentation. I hope you got something good out of it. If nothing else, a good refresher. Thank you for the privilege of your